Welcome everyone for the last day of our digital space sustainable logistics digital symposium. I'm very happy to have you for this final day. Our symposium continued yesterday with a focus on logistics in space and on Earth. Professor De Weck took us on an amazing journey on space logistics, starting from the Antarctica in the 19th century. He talked about how new logistics network in space, in situ resource utilization, and the generalization of reusability will be a paradigm shift that would allow mankind to get back to the moon and also beyond to Mars. Klaus Dorman from DHL offered us a deep dive on how Earth logistics expert DHL pushes the innovation and which are the proven recipes that can eventually also help and inspire space logistics experts. Finally, during the panel discussion led by Euroconsult with new space actors such as The Orbit, OrbitFab, Astroscale, and Ariane Group, we talked about the drivers of space logistics, the 5 to 10 years maturity perspective of this industry, new businesses model, and the need for a legal framework in order to follow the growth of the new space activities. Today, we'll have 3 sessions during this last day. First, we'll have a keynote speak by Muriel Ricciardo, which is ClearSpace Chief Engineer and co-founder. She will talk about the ClearSpace-1 mission and how ESA and ClearSpace team up to remove debris. Then we'll have a second panel discussion with our partner Brian Whedon from Secure World Foundation, talking about the pathways for developing rules for space logistics. Finally, we'll have also a panel discussion with Claude Nicolier, astrophysicist, and professor emeritus at EPFL and Space Innovation, talking about the future perspective of space logistics and sustainability. Before I give the floor to Muriel, I'd like to remind a few housekeeping rules. First, we'd like to ask you to turn off your camera. We also remind you that the videos will be available shortly on our YouTube channel. All bio of the speakers are available on our website, so if you want to learn more about them, you can go and check. And finally, questions are moderated through the chat, so if you have any question for the speakers, please ask them to the chat. And now, I'm really pleased to introduce Muriel Ricciardo, ClearSpace Chief Engineer, who's going to tell you about their mission. Muriel.
Thank you, Emmanuel. Can you see my screen? Emmanuel, can you confirm that you're seeing my screen?
Yeah, we can see.
Very good. So I'm part of a story here that goes much more beyond what we are and what we're trying to do. But the story really started after the after the coming out of the OneWeb constellation, where we realize that there is an exponential coming up, and the exponential is here actually, showing the number of, here this graph is showing the number of new space elements that are being sent every year. So satellites, of course, being sent every year since the 60s, when the whole space adventure started, all the way to where we are today. And this exponential has been enabled basically by those 4 different elements. The cost of the access to space has dropped significantly. The technologies that are needed, the maturity of the technologies that are needed to now produce satellites in mass, in line, is ready. And the launch rate of LEO is something that is happening and is doubling every day. So the conclusion there is that something needs to happen. In-orbit services are needed in order to to promote and to sustain a viable space economy. So on top of this trend, we had been working at EPFL for quite some time on figuring out solutions for another trend. And the other trend is pictured here. And that other trend is becoming very crowded. And so it's a good thing. It means that more and more we're going to be using space for infrastructures that will support economies, that will support people's lives. At the same time, this picture shows that this is not anymore one street on one road that we're building, and that the few cars that when we started having cars on the streets would use, but now we're having a problem of management. We have many, many freeways that are being used, many, many cars on freeways. And so whatever happens right now today on ground, it's also happening in space. So this increase in the space utilization and this increase in space objects is also shown in this other graph that shows in the x-axis the altitude, and then in the y-axis the number of objects. And it also shows the differences between March and November 2020. And you can see that to about 900 kilometers, there is a large bump, and that bump has been created by collisions, explosions of debris, and creating exponentially more debris. And then the new coming constellations, as we see here, the peak of the Starlink satellites. So the question that we may ask ourselves is, how can we help operators? How can we help them have safe environments? How can we be part of a sustainable circle in this economy? And really, how does the contract, the service, our first client, which is ESA, the service contract that we have with ESA, how does that mission help this big picture? So I'm going to give you a little bit of information about that mission. ESA has issued a service offer request at the end of 2018, to which ClearSpace responded. At that time, ClearSpace had 0.4 employees. So we really wondered, should we do this or not? We said, there is nothing to lose. And so we decided to respond. I think that the years that we had spent at EPFL working on the problem helped a lot with the content. Surprisingly, we were shortlisted, went through a second round of proposals where ESA asked, why do you want to do this? What do you want to do? And so here again, we were very honored to be selected and to be trusted by ESA as a startup, to be selected to actually provide that service. Before going to actually implementing the service, we had to find the funding, and the ESA funding comes from delegations. So we had to go in a campaign where we proposed to industries and different delegations in Europe. And they also showed their trust in us with providing the sufficient funding for us to start the ClearSpace, the address ClearSpace-1 mission at the end of 2019. At that point, we responded to the third proposal, which was explaining the how are we going to do the mission with a lot of details. And that led to a beginning and a start of that mission in July 2020, and a contract signed in November of 2020. So we're right now in this preliminary design phase. And what we proposed, as you can see here in this picture, is to remove the VESPA upper part. This part is actually a part of the structure that flew on the VEGA VV02 of the VEGA launch vehicle, and that hosted on top of it the PROBA-V satellite. And that part was released into an orbit which is between 600 and 800 kilometer altitude. And the VESPA was out of the list of the 22 elements that ESA proposed to remove. The VESPA was actually the smallest and the lightest. But us being a startup and being reasonable with what we expected we could do at that time, we selected this target. It's about 112 kilograms. It's about 2-meter diameter, about 1.8 meter in height. And for us, it was a clear de-risking target. Making a rendezvous with an uncooperative object is something which is complicated. And in this case, the target doesn't have solar panels. So it kind of simplifies the problem. So that, that target, it was a clear de-risking element. The servicer that we designed and that we're still designing and improving, for us is a space robot. A space robot that has to have sufficient autonomous navigation to do the rendezvous with this object, the VESPA, which is an uncooperative object. So there is no center on it that would help us do the rendezvous. There is no markers on it that would help us doing the rendezvous. There is no predefined docking interface that would help us doing the rendezvous. And finally, it's a tumbling object. So it's an object that will be having rotations that we are characterizing with ground observations. But it's not like a typical docking mission where both objects would be stable and coming close at each other without moving, meaning moving very slowly. Here in this case, the object being tumbling, we're going to have to follow its motion in order to capture it safely. So the satellite has to have the features of a space robot, which can do autonomous navigation, and that has agility, so ability to transfer and move itself in space, but also around itself in a agile way. So our satellite is around 400 kilograms, 600 watts or so. It's a 1.2 meter side cube. And as I said, we're in the preliminary design for it. And so how does that really relate to the problem? This is a high-level sketch of what we're going to do. We're going to be launched in 2025 on an orbit which probably will be lower than the operational orbit, such that we have favorable conditions to catch up with the orbit of VESPA. And when there is this alignment between our orbital plane and the VESPA orbital plane, then we'll do a propulsion maneuver to go up and then do the rendezvous and capture the element, detumble, because it's going to be tumbling, so we'll have to detumble, stabilize, and do, again, the Albertine burns. I don't know what I should do with this. Okay. deorbiting turns to come back down in the atmosphere. Now, this is the technical part of it. There is another reason why we work like crazy for this mission. The other reason is related to my example of the automobiles and managing the traffic. In the last 50 years, the trend for an operator, or a similarity for the operator, was to actually buy a new car, which was a new satellite, expensive satellite, and fill it up with propellant, and then go on the freeway and start driving on the freeway, so meaning accomplishing its mission, all the way to either at the end of the mission be still in a safe configuration and be able to deorbit itself, so exit the freeway, or what could happen before is either run out of fuel or have a mechanical or an electronics breakdown. So really what we're after here is all these cases that cannot be controlled. I'm not sure what I should do this. Cannot be controlled and that require fixing. So operators, and to their rights, are always trying to do repairs, to try to understand what the failure is, and do their best and work on it for 6 months or so, and it could be more, and then at some point they may declare that they can't do anything anymore, and that's okay, because in fact they did their best effort, and this is what they could do. So it was okay, and it still is okay for them to leave the satellite on the freeway. What's important to me, and I think to the whole company here, is that with this ClearSpace-1 mission, we are going to demonstrate the ability, the capability, and the feasibility of a tow truck service in space. As soon as you have a tow truck service on the freeway, it completely changes the operating environment. And what you called the best effort before becomes something different today, because when you're in the freeway and you have a problem, there is a tow truck service. That tow truck service is affordable, and you can call it. And by calling it, it removes the car. And so from our point of view, this mission will allow us and will be a tilting point in the way the operations are thinking about the end of life, or are thinking about what happens when we leave the car on the freeway. Not only the operators, but hopefully also the launching states, which ultimately are liable for the assets that are in space. So what I'm trying to get to is it's a beautiful technological challenge. It's a fun mission to work on, and it's also a service that we believe will have more than just the technical impact, but also a behavior impact. So improving the sustainability of space operations. And we're hoping to be able to bring that service and to bring our asset, what we have in mind, into the community here. So this is the high level milestones of the project. So we started in July. We have a preliminary service phase where we will have a key performance gate. Those are formal may say go or no go. And they have been investing about 86 million in us, and for sure they should monitor what we're doing, making sure that we're on the right track. and having the ability to say, oh, okay, we need to stop because this is not corresponding to what we're thinking. We have currently a great team at ESA that works with us. And so we are preparing key performance gate #1 in about 6 months or so. Then we'll have another service phase, which follows the typical development process. But the launch is planned for mid-2025, and we'll have about 7 to 8 months of operations before removing VESPA from its orbit. So really, what does ClearSpace bring in? And ClearSpace is a producer of subsystems, and at the same time a mission and system designer and the operator. And so we have specialized in the technologies that are needed, that are specific to in-orbit services and active debris removal, like the navigation, the sensors, and the robotics part. And for the more conventional but extremely important other part of the service, the flight service, but also the ground service, we have selected about 20 subcontractors, so 20 partners that are located in 8 different countries in Europe. And you see a few of them there. And the way we work with our partners is to make sure that we are doing what we call co-engineering, so making sure that we're benefiting from all the brains that are in these great companies to have a product that makes sense in the end and that is affordable. So this is my last slide. In summary, the ClearSpace-1 mission is a great opportunity that ClearSpace has now for this first client. It's not only an opportunity to remove a space debris, an opportunity to demonstrate the whole phases of the service, from the development all the way to the flight, all the way to the disposal of the mission, so the whole end-to-end operational scenarios. But it also, we believe, and hopefully will be a game changer in the way that the operators will think about end-of-life operations. So this is what I wanted to convey to you in this 20 minutes or so. And I'll be happy to respond to any questions that that Emmanuel, you may have already selected.
Thank you. Thank you, Muriel, for this really good presentation and to get the insight of the ClearSpace-1 mission and also how you all came to this. So we have a lot of questions. Few are kind of technical. First question, how many objects can this mission deorbit before it runs out of fuel? Is it possible to use electric Hall effect thrusters to be more efficient with fuel?
So this is a first client or first mission per se. So here our objectives are to deorbit only the VESPA. So the way the satellite is designed and the choices that we have made will allow us to remove that item. Of course, in the future, for the future commercial service, one servicer will be able, like the tow truck on the freeway, one servicer will be able to really remove more than one object. And then the second question was?
The second question was, is it possible to use electrical Hall effect thrusters to be more efficient?
So yes, of course, it is possible to use electric propulsion in order to reduce the fuel that you need for the removal of several objects. Yes, Hall effect thrusters. There are other thrusters. We haven't decided. We're looking into this.
Okay, Thank you for this answer. Then I see there's a few questions about the capture system, so I will ask them, and so maybe you will just explain a bit more about the capture system. So what is the actual technology for target the capture for the capture system? Then there was also a question asking, sorry, it's moving so fast. Yeah, what is how long is actual space operation for target the capture? For target capture take, is it planned to be completely automatic?
3 questions, right? Okay. So the technology that we selected is the tentacle system. So 4 robotic arms, if you wish, that will enclose the target in a volume, which is a predefined volume, and will detect when the object is inside the volume, and once the object is in the volume, will close in order to secure the target. There are, of course, many, and we have seen demonstrated, successfully demonstrated other technologies like the net, like also robotic arms. We had the remove debris mission that also demonstrated the use of harpoons. We decided to go for this tentacle system because it also inherits from the work that had been done at EPFL the years before, where we had designed a mission that hasn't flown yet, but called ClearSpace-1, with the purpose of removing a CubeSat. And so for the removal of the CubeSat, we had basically 4 to 5 arms that would deploy and then englobe the Swiss cube. So we inherited from this. The operations could be done. The way we see this in the commercial operations could be done relatively fast. We will take our time for this first mission. We want to make sure that every step is has go no goes, internal or with ESA, just to make sure that everything is nominal. But so this is why we're going to take several months. But after this, the recurring would be much faster. And one of the elements that needs to be demonstrated is the level of autonomy that we will be able to achieve during our operations. So yes, as much as we can, we're putting autonomy and automatic, if you wish, procedures, such that the operations are done autonomously but supervised.
Thank you for those answers. Talking about autonomy, one of the viewers were asking, what sensor suite will you use for autonomous navigation?
So we will rely on visible sensors, and we will test other types of sensors.
Okay, thank you for this answer. Another question is there a soft material used on the inside of the arms to protect the target from damage? What is it made of? A lot of tricky questions.
No, it's a great question. We are making the capture system such that it's able indeed to cope with misalignments of the navigation. And so that can indeed absorb a certain level of shock. And you're absolutely right that it's one of our main concern to make sure that we don't create more debris, either on the target or, of course, on our servicer.
That's true. And that leads me to the next question about like, how are you planning to detumble the target?
So once the target is secured, the detumbling phase is not that difficult. We have a propulsion system on board with small thrusters, and those will be firing in the right sequence, such that we actually stabilize what we call the stack in a few tens of minutes. So it's relatively short time to do.
Okay, thank you for this answer. Next question, more on the business case. They say, obviously 100 million for one object isn't sustainable. How many object removes per mission, and at what cost does it become sustainable?
Yeah, it's a great question, and I wish I had all the answers for you. This is something we're working on. We have our own targets for the how affordable this tow truck service should be. We have our own idea. I think it's once this mission will be flown, and I know that there will be other similar missions being flown, that we will really have the true answers when the clients actually start buying the service for a price that they feel is right. So the answer is today. Today I don't know. Very soon we will know better.
Yeah, sorry. There was also a question about a viewer asking if you're planning to remove another object on this mission, or it's really a one object mission for ClearSpace-1.
Yeah, that's I think it relates to the first question. Yes, this is a one-shot mission.
Okay. Oh, that's a good one. Given the scarceness of in-situ space data for close proximity operation, how can we address the gap between simulation and reality?
Maybe I'm gonna sidetrack. I will come back to your question, Emmanuel, but maybe I should add this other element. When ESA requested for a removal service, there were 4 requirements basically put on the table. And the first one of this requirement is that the deorbiting should be done before December 2025. And so when we looked at the time it would take for the whole process with ESA to get to the closure with the signed contract and the development time that we needed, it really pushed us for a certain type of propulsion system. And that propulsion system it does not have a very high efficiency, and so allows us to only do one target. If the requirements had been different, I believe we would have tried to go for another target after this first one. But the constraints in the problems that were provided to us led us to a service that right now removes that object, which is already quite something to do. So I'm actually quite glad about that too.
Indeed, it's also a first,
That's right.
is the first mission of this kind. So now, yeah, the question we had asked was about, given the scarceness of in-situ data for close proximity operation, how can we address the gap between simulation and reality?
I think that's a great question, and I would have 2 answers to this. There is already some heritage that we can benefit from. So companies that have done similar operations that are part of our consortium. And the second thing is this stepwise approach that we have taken, which makes sense. I think everybody would take the same steps in the end, but making sure that as we go along in the approach, in the rendezvous, in the close proximity operations, we stop and we say, are we good? Are we still good with respect to our plans? Do our sensors provide the same accuracy that we're expecting them to provide? And then really think through and make necessary verification before going to the next phase. So I think this approach, of course, de-risks a lot of the things that could happen, which are very difficult to validate on the ground.
Thank you for your answer. So I ask one last question, which is going to be also a great transition for our next panel. You mentioned also the parallel with the tow truck, and one of the viewer was mentioning it's nice, but it's true that on Earth, if you leave your car on the highway, then you will be fined. So, and there is no such system in space. And then, yeah, so that's why the next question is how ESA, NASA, or government is going to enforce space players to remove their debris from orbit. What is your view on this topic?
So it turns out that through the ClearSpace-1 mission, the previous one that we started at EPFL, we got to be invited in the United Nations meetings. So there's a branch of the United Nations that deal with everything that has to do with space assets and military aspects of the space assets also. And we were invited there to present the status of the project, also mostly for transparency purposes too. And so, yes, while attending those meetings, I could see, but this is my personal opinion there, but I could see that it will take a long time to get an agreement and between all the countries that are concerned. There are too many other elements that, like for instance, the dual purpose of the type of technologies that we're talking about, that will put a brake on, you know, the involvement of countries or the commitment of countries to actually do something. We are more believers in the fact that we need 2 or 3 big spacefaring nations to take the step to include that into their national laws, and then have the other nations follow the behavior, in fact. So this is what we are looking after.
Great. Thank you very much, Muriel, for
Thank you, everybody.
your thoughts on this, for this
Thank you.
great presentation on your mission, also answering all those questions. I think viewers now have a better understanding of the concept of the mission, on the technical aspects also.